Hey guys, Mrs. Stans here. So today we're on lesson 9. We will be creating equations and inequalities in one variable and use them to solve problems related to consecutive integers. So last year you did do some consecutive integer problems. So we'll start off with some fairly easy ones. They'll get a little more difficult as we go on. There is a do now on page 45. And your homework answers were posted in yesterday's post, but they're posted here as well. So I do want you to make sure you check over your homework answers and ask me questions when you see me. Today we are going to do numbers 3, 2, 7, 4, and 9 in that order. Picked it in that order for a reason. And instead of having you do all of your homework, I'm asking you to do numbers 1, 4, 5, 6, and 9. Notice that I want to do 9 in class, but if I don't get to it, I guess I'm giving it to you for homework. And you can do more problems for extra practice, and a list of the answers is posted in your Google Classroom. So let's go over the do now, talking about the definition of consecutive, one right after the other. But we always talk about consecutive integers because you can't do consecutive real numbers because remember, real numbers are infinite in between whole numbers. So we can talk about consecutive integers. Remember, integers are the whole numbers and their opposites. So if we were to list any 3 consecutive integers, I don't know, I could pick 10, 11, 12. And the question is, how much must you add to any integer to get to the next integer, right? To get from 10 to 11, I'm adding on 1. To get from 11 to 12, I'm adding on 1. So to get from one integer to the next, we add on 1. Now let's talk about odd integers. Any 3 odd integers? Sure. 3, 5, 7. And how much do you add from one odd to the next? Yes, we do add on 2. Next, we're going to talk about consecutive even integers, things like 2, 4, 6. And to get from one even to the next, we're also adding on 2. So that's something interesting to note, that to get from one odd to the next odd, it's an add-on 2. To get from one even to the next even, it's also an add-on 2. To get from one integer to the very next one is just an add-on 1. So that helps us greatly with our let statements. So when we're doing word problems, we like to do let statements. Yesterday we did word problems with geometry. We did let statements, believe it or not, it was just in diagram form. I can't draw a diagram for integers, so we do let statements, and we usually let x equal the first integer. Now, right now, we're just talking about consecutive integers, and we had said that you only have to add on 1, so the next integer would be an x plus 1. If I wanted to do the third integer, I'm adding on 1 to this x plus 1, which gets me to an x plus 2. So you keep on adding on 1 to get from one integer to the next. Integers go on forever, so I'm just going to put a dot, dot, dot here. If ever I'm going too fast, of course, hit pause. Consecutive even integers. We said that they were 2 away from each other, and we also said that we always let x equal the first integer. Now, instead of saying first integer, since it's very specific with even, I want to put that word in there. It's the first even integer. I'm going to abbreviate my word integer. But to get from one even to the next, remember over here it was an add-on 2, so x plus 2 would actually be the second even integer. Now let's just imagine this for a second. X is standing for any even integer. Maybe x is the even integer 2. If I add on 2, I get to 4. If I add on 2 again, I get to 6. Oh, that's wrong, not a plus 2. Add on 2 again, which brings it up to an x plus 4. Sorry about that. But you keep on adding on 2, and that's how you get to the next even. And then this is what baffles people's brains when we do consecutive odd. So again, let's let x equal the first odd integer. And what did you tell me we're supposed to add on to get from one odd to the next? It is add on 2, therefore this next statement is x plus 2. And it gets me to the second odd. And then an x plus 4 gets me to the third odd. And so on. And then some people say, wait a second, Mrs. Dans, you made a mistake. We're talking about odd integers here. Why are you adding on 2? 2 is an even number. Yeah, that add on is not the number, right? Remember, this x represents an odd integer. Maybe this x is representing the number 5. If I add on 2 to the 5, don't I get to 7? Right? So I do get from one odd to the next. I'm just going to erase these numbers because that's not really the numbers. I was just trying to show you that the variable represents an even number in this case, and the variable represents an odd number in this case. So that's how come we have to add on 2, because even integers are 2 away, odd integers are 2 away. So the first problem I wanted to do with you is number 3. Let's all turn to number 3. So it says find 2 consecutive integers. Okay, just consecutive integers. And I'm not going to even read any further. Since I know it's consecutive integers, I'm going to do the set of let statements for consecutive integers. Let x equal the first integer, and x plus 1 is the second integer. They only wanted 2, so all I need is 2 let statements. After these words such that, it tells you what your equation is. So it says such that twice the smaller. So if I go look at these 2 integers, one of them's x and the other is x plus 1. Which one's smaller? Of course, you're right. The first one is the smaller one. So I'm actually even just going to write that here. This one is smaller. Therefore, this one is the larger one because I added on 1. Of course, it's bigger. And I have to do twice the smaller. Twice means 2 times. Twice the smaller. Right? So you take your let statement and put it in place of the smaller one. So it says twice the smaller is. Is an important word. It stands for equals. Twice the smaller is 12 more than the larger. Remember that 12 more than means I'm adding 12 onto something. What am I adding 12 onto? The larger. The larger one, remember, was x plus 1. So here I go. I just translated pretty much word for word. Take a look as I'm going to highlight actually as I'm reading it. So this is twice the smaller is 12 more than the larger. I think I have to erase some of this highlight though, it got in my way. And now let's solve this equation. So this is 2x equals x plus 1 plus 12. I just rewrote it without the parentheses. I simplified it. And over here, I want to combine my like terms. And now to solve for x, I want to subtract x from both sides. And I get that x is 13. If we go back to our let statements, we can find both integers. The first one, I guess, is 13, and the second one is 13 plus 1, which makes it 14. The integers are 13 and 14. Remember, they're supposed to be consecutive, so it makes sense that the one right after the other, and it didn't say anything about even or odd. The next number I wanted to do was number 2. So this one is asking for 4 consecutive odd integers. So we always start with let x equal the first odd integer. Since they're odd, they're 2 away from each other. So x plus 2, I do need 4 of them, so I'm going to need another and another. So I have the first odd, the second odd, the third odd, and the fourth odd. Again, if I'm going too fast, you hit pause. But here are our 4 odd integers, because odd integers are 2 away from each other. And now it says such that the sum of the first 3, the sum of the first 3. So here's the first 3. The sum of the first 3 would be x plus 2 plus x plus 4, right? That's the sum of the first 3. That's all I did so far, the sum of the first 3. And this is the part where it gets tricky. It says that the sum of the first 3 exceeds the fourth by 18. So this is the sum of the first 3. And that stuff exceeds the fourth. All the way over here, I'm going to write the fourth. The fourth one is the x plus 6. Do you agree? So the sum of the first 3, exceeds the fourth. What does it mean to exceed? Yeah, it like beats it. It's bigger than it. It's bigger than it by 18. The sum of the first 3 is already bigger than the fourth one by 18. So the fourth one is actually the smaller side, right? The sum of the first 3 exceeds the fourth one by 18. If I want to put an equal sign in here, I better give this 18 more. And this is the part that I need you to understand. I'm just going to erase this equal sign again and erase this 18. Right now, I'm showing you the sum of the first 3, and then I'm showing you the fourth one, and right here it says that the sum of the first 3 exceeds the fourth by 18. The sum of the first 3 is bigger than the fourth by 18. So let's make them equal by giving the smaller side 18 more. And now we're going to solve. We'll combine our like terms. So we get 3x plus 6 equals x plus 24. And if we subtract x from both sides, and then subtract 6 from both sides, finally divide by 2, I get 9. Thank God it's odd, because we were looking for an odd. So that's also another nice thing about these consecutive integer problems. If it turned out to be even, I know I made a mistake. If it turns out to be a decimal, I know I made a mistake. We could go back to our let statements now. The first one is 9, 11, 13, and 15. And those are our integers. So this exceeds stuff you just got to be careful with. Next, I want to do number 7. So find the three greatest consecutive integers such that the sum of the first and the third is less than 41. So this is an inequality, right? Find the three greatest, that's a hint right there, consecutive integers, and over here less than. So consecutive integers, let x equal the first integer. X plus 1 is the second integer. And x plus 2 is the third integer. We wanted 3 of them. We go to the such that the sum of the first and the third, the first plus the third, the sum of the first and the third is less than 41. And some people say, you must have made a mistake, Mrs. Dans. You didn't use the let statement for the second integer. There is no rule that says you have to use all let statements. Sure, there has to be a let statement for the second integer because there are 3 integers, but we don't have to use that second integer in our equation. It says the sum of the first and the third is less than 41. So let's solve this. You get 2x plus 2 is less than 41. So 2x is less than 39. Divide by 2. And some of us might be thinking we made a mistake. I got 19.5. I thought I just said that it's great to do these consecutive integer problems because you'll know you made a mistake if you get a decimal. Well, we didn't make a mistake, but we actually didn't get a decimal because it says x is less than 19.5. So what integer is less than 19.5? It has to be 19. Right? We're going to use 19 as our answer. So we'll go back to our let statements and say that I guess this one's a 19. Therefore, this one must be 20, and this one must be 21. Find the 3 greatest consecutive integers such that the sum of the first and the third is less than 41. So 19, oh, I made a mistake. No, I didn't. 19, 20, and 21. I said that the sum of the first and the third has to be less than 41. Just test it out for a second. Is 19 plus 21 less than 41? It sure is. It's 40, right? So these are the answers. So when it's an inequality, please be very careful. Okay? This right here was just like a check. You could do things to check yourself out. Just going to get rid of it though. Next problem I wanted to do is number 4. So the ages of 3 brothers are represented by consecutive integers. All right, so I'm just going to write my let statements right away. Let x equal the first integer. X plus 1 is the second integer. And x plus 2 is the third integer. Now they did say that these are 3 brothers, right? And their ages are represented by the consecutive integers. So over here, when they're talking about the oldest, which one is the oldest? Is it the first integer, second integer, or third integer? Yeah, the third integer, right? Because it got more added on. So I'm actually going to write that this is the oldest. Therefore, this first one is the youngest. It'll make it easier for us to answer parts of this question if I call them oldest and youngest. And I guess this is the middle brother. Anyway, so let's read. So if the oldest brother's age is, I'm just going to stop right there. The oldest brother's age is, remember is means equals. So the oldest brother is I guess I read a little poorly. I'm going to erase what I did. I didn't finish reading. Is decreased by. See that? We all make mistakes. So it isn't the oldest brother is. It's the oldest brother is decreased by. So that's a subtraction sign. He's decreased by twice the youngest brother's age. Twice the youngest brother's age. So let's read that all together to make sure I didn't confuse anyone. So I'm going to highlight again as I read. The oldest brother's age is decreased by twice the youngest brother's age. And then it says the result is negative 19. The result is, that's our equal sign, negative 19. And how old is the youngest brother? So this has to be solved. So we have an x plus 2 minus 2x. When I combine like terms, I get negative 1x. So I'll subtract 2 from both sides. Negative 1x equals negative 21. Divide both sides by negative 1. X is 21. So in this case, since it's the ages of brothers, a negative answer wouldn't have made sense. So I'm so happy that I had to divide by a negative, and negative divided by negative is positive, because now it makes sense that someone could be 21 years old. So I guess the youngest brother is 21, the middle brother is 22, and the oldest brother is 23. The question is, how old is the youngest brother? So the youngest brother is 21. And the last problem is number 9, which also is a homework problem. So let's get it started. Oh, I'll just do the whole thing with you. I won't even just get it started. I like this one. This one's kind of like proving things. It's not solving something. Notice how it starts off. It says show that the sum of 3 consecutive integers is always equal to 3 times the middle. So we're talking about 3 consecutive integers. So let x equal the first integer. X plus 1 is the second integer, and x plus 2 is the third integer. We need to show that the sum of the 3 consecutive integers, so let's do that. The sum of the 3 consecutive integers means I just add them all together. And I want to show that the sum of these is always equal to 3 times the middle number. 3 times the middle number, right? This one is the middle number. So the sum of the 3 integers is always equal to 3 times the middle integer. So how am I showing this? Well, I'm just going to simplify each side. So I'm just going to get rid of these parentheses and then combine like terms. Notice how I always simplify by getting rid of my parentheses before I combine like terms. So the left side turns out to be 3x plus 3. On the right side, I have to distribute, and I get 3x plus 3. Guess what? This is an equation that has an infinite number of solutions, right? If this has an infinite number of solutions, didn't I just prove that the sum of 3 consecutive integers is always equal to 3 times the middle? Right? It always is. There's an infinite number of solutions here. It always, always, always works. And if you don't believe it, let's just test it out. 3 consecutive integers. I don't know, 1, 2, and 3. They say that the sum of them, so if I add this, I get 6. 1 plus 2 plus 3 is 6. They said that the sum of it is always equal to 3 times the middle. 3 times the middle is also 6. Hey, look at that. I just randomly picked 3 integers and it worked. And you could pick another 3 to prove it. 10, 11, 12. The sum of those, 10, 20, 33, and 3 times the middle is 33. Look at that. It really does always work. But anyway, your homework, I told you, was to do numbers 1, 4, 5, 6, and 9, but I just did 9 with you. I have a list of your homework answers in Google Classroom so that you could see if you did it right or not. I also have a list of the homework answers from last night so that you could see which ones you need to ask me. And you can work on your homework and be ready to ask me questions when you see me. I hope you have a great day. Work really hard. Remember, we have a test coming up. All right. See you soon. Bye.